Friends, today we are going to discuss a very important equipment installed in every industry. That equipment is called boiler. We install boiler to generate steam, and steam is having lot of energy inside. The steam is used to drive turbine to generate power. The steam is used for heating purpose, and so many other applications are there in the industry. So we need to learn boiler. But before going to discuss in detail about boiler, we want to just give you some idea about the properties of steam. What is steam and what are the parameters the steam is having? So if we discuss the water and formation of steam, water has three phases, namely the ice, water and steam. When the ice melts, there is a transformation of phase from solid to liquid. Ice melt, this ice, solid to liquid, solid to liquid, solid to ice melt. When the ice melt, there is a transformation of phase from solid to liquid, which is called melting, which is called melting, which is called melting or fusion of ice. If the transformation take place from liquid to solid, from here to here, liquid to solid, then it is called freezing. It is called freezing or solidification. Similarly, transformation from liquid to vapor, it's liquid to vapor phase is called vaporization. It's called vaporization, and gas to liquid, it is called condensation. It is called condensation. And then if you from gas directly to a solid, it is called crystallization, and from solid to gas, it is called sublimation. It is called sublimation. So if we heat ice of minus 10 degrees centigrade at a constant pressure of 1 atmospheric pressure, one atmospheric pressure, here it is 1 atmospheric pressure, then it start melting, and heat is to be added till then heat is to be added till ice is completely melted. This ice is completely melted. It is called the latent heat of fusion. Uh, from 0 degree, minus 0 degree to 0 degree, first it will come, still it will be ice form. Then again you heat it, then from all the ice will be melted and it will become 0 degree liquid form. 0 degree liquid form. Heat is to be added, it is completely melted. It is called the latent heat of fusion. At 1 atmospheric pressure, the numerical value of latent heat of fusion is 80 kilocalorie per kg. 80 kilocalorie per kg. The word latent heat comes from the fact that the temperature remains constant at 0 degree centigrade till till ice completely melted, and then through heat, and even though heat is added, the temperature remains same, and then all ice will be converted to liquid. You see the temperature and Q figure TQ diagram. TQ diagram. It will be like this. First we heat ice to heat, from it will be minus 10 to 0 degree centigrade. Then ice become liquid at 0 degree centigrade. This heat is called latent heat of fusion. Then all ice when become liquid at 0 degree centigrade, then again heat it, temperature will go on increasing. That is called sensible heat. Then when the temperature will rise to 100 degrees centigrade, then you further heat it. This is called the latent heat. All liquid at 100 degrees centigrade will become vapor. This is called latent heat of latent heat of vaporization. And then all liquid become vapor, and then you further add the heat, its temperature will go on increasing. That is the heat of superheat. heat of superheat. So liquid to solid, when we are liquid to solid, we are call it liquid, call it freezing, and its A is called latent heat is called 80, latent heat liquid is 80 kilocalorie per kg. Solid to liquid, it is again called melting, and then it is also 80 kg per 80 kilocalorie per kg. Liquid to vapor, liquid to vapor, liquid to vapor, it is called vaporization. The latent heat is required, this latent heat is required, this much latent heat is required, D to E, that is called, that is value is 540 kilocalorie per kg. And then again from suppose from gas to liquid, want to come back gas to liquid, it is called condensation. There is condensation. At the time 540 kilocalorie per kg of steam need to be taken out, then gas will convert it to liquid. Next is this. On further heat is added at constant pressure of 1 atmospheric pressure, atmospheric pressure of 1 at atta, the temperature increase up to 100 degrees centigrade, that we have seen, that is called sensible heat. And then water just start boiling. The heat added to for changing the water from 0 degree centigrade to 100 degree centigrade is called sensible heat. For 100 degree centigrade. Then water at 100 degree centigrade at this point is called the saturation. The water at 100 degree centigrade at this point is called the saturated liquid. This temperature is called the saturation temperature, because water is in saturated liquid state at this point. Then further addition of heat will result into vaporization of water. The temperature remain constant till all water is converted to steam. This heat is added during this vaporization. It's called the latent heat of vaporization. Its value is 100 degree centigrade at 100 degree centigrade 1 kg per centimeter square. Its value is 540 kilocalorie per kg. 540 kilocalorie per kg. So this stage is waste steam zone. This stage is called dry saturated vapor. This is the saturated liquid. Here liquid. This is the dry saturated vapor, and here it is called the critical, and here it is the solid phase. That is PV diagram. It is PV diagram. PV diagram. Here the temperature and volume diagram is like this. Minus 40 to if you go on increase the temperature, you see from temperature volume will increase. Then it will be it will, if you further heat it, then temperature is 0, then 0 to 4 degrees centigrade, volume will remain same. Then further temperature, water will go, your temperature will go on increase by 100 degrees centigrade. Then again you have to give the latent heat of vaporization, and then all the gradually all the water at 100 degrees centigrade will become the vapor of 100 degrees centigrade. Then further increase the further you have to, if you add the heat, it will become superheat. So this is also the same thing. Liquid minus ice minus some degree centigrade, increase it will become 0. Then from freezing, melting, then melting take place. Then again 0 degree centigrade up to 100 degree centigrade, it is called liquid. It will remain liquid and temperature will increase. That is called the sensible heat. At 100 degree centigrade, you have to add the evaporation, latent heat of evaporation, and then all steam become, all liquid become liquid of 100 degrees centigrade become steam at 100 degrees centigrade, and further increase will give you the water will be high temperature, superheated steam will be there, will generate. Then dryness fraction, the mixture of the steam and water is called the wet steam. The mixture of steam and water is called wet steam. The relatively the amount of each phase present in the wet steam determine the quality and dryness fraction of the steam. Quality of the steam, how much present of wet steam is there. Suppose the quality or dryness fraction of steam is X, is defined as the ratio of mass of dry steam, X is the mass of dry steam plus total mass of mixture, that is MS steam plus MW means water. So this is called the dryness fraction. That is mass of dry steam, that is mass MS plus mass of mixture, means dry steam plus water. So this is called the dryness fraction. This is called the dryness fraction. Then superheated steam. superheated steam, if you further if you increase once addition of heat, the saturated steam become its temperature go at constant pressure, the temperature increases, go on increase, then again go on increase. This process is called the superheating steam, and the resulting steam is called the superheated steam. Then if further increase, the steam is called the superheated steam. The heat is added, is called the heat of superheat. The difference between the superheat temperature and the saturation temperature is called the degree of superheat. If you suppose your temperature is 120 degrees centigrade and saturation temperature 100 degrees centigrade, so the 120 minus 100 is equal to 20, that is equal to the degree of superheat. And degree of superheat at different pressure, the nature of given shape means liquid will solid will become to 0 degree, or ice become 0 degree centigrade minus to 0 degree centigrade, then converted to liquid at 0 degree centigrade, then again temperature will increase to 100 degree centigrade, then again temperature, all the liquid will become vapor, and then go on increasing the temperature at superheat. At different pressure, the nature of process will be the same. This process will remain same, but the saturation temperature will be different. Different pressure, saturation temperature will also be different. Latent heat of vaporization will decreases when the pressure increases. Pressure increase. Latent heat of vaporization will decrease when pressure increase. If you see the diagram, it will be totally clear to you. When pressure increase, this pressure increase, you see the latent heat of, this is called the latent heat. This is the latent heat. So this is the latent heat will come down. This is the latent heat will come down. And low pressure, latent heat is more. At higher pressure, latent heat is less. Latent heat is less. Latent heat is less. And there will be a certain position at particular phase. It is called the critical pressure. The water directly convert into steam without latent heat. Without latent heat. At particular this phase, you see, at particular this phase, there is no need of any latent heat. The water become directly to converted to steam, directly converted to steam. There is no latent heat is required. There is no latent heat is required. This pressure is called the critical pressure. This at 225.05 degree kg per centimeter square, the water square, and at the particular at the temperature, the corresponding critical temperature will be 374.14 degrees centigrade. The water become directly converted to steam. There is no need of any latent heat. There is no need of any latent heat. At that particular position, the density of water and steam at this particular pressure and temperature, the density of water and steam will be the same. Will be the same. This point is called the critical pressure of water or steam, that is 225.05 kg per centimeter square, and temperature is 374.15 degree centigrade. Next is thermodynamic properties. Till now we have learned about temperature and pressure. Now we are going to learn about the other properties of steam, that is called the specific volume, that is called enthalpy, that is called internal energy. Another one is called entropy. What is specific volume? Now for the volume of 1 kg of steam is called the specific volume of steam. Enthalpy of steam is the heat content of the unit quantity of steam, that is called enthalpy. How much heat is there per kg of steam, that is called enthalpy. Internal energy, the internal energy of thermodynamic system is the energy content within it. How much energy is there inside, that is called the internal energy. Entropy, the change of entropy of steam is the heat transfer per kg per unit temperature difference. Per unit temperature difference per kg of steam, what is the heat is transferred, that is called the entropy. These four things are very important, parameters are very important, that are going to learn now. Now, the properties of the steam are normally tabulated in a tabular form, in a engineering tabular form, that is called the steam table, where everything at pressure, temperature, latent heat, etc., everything you will get. At a particular temperature, particular pressure, what is the latent heat is there, everything we will get from the table, that is called the steam table. Apart from that, we can get this value, means your enthalpy, latent heat, your temperature, saturation temperature, superheat temperature, everything, specific volume, etc. we can get from a diagram. This diagram from the diagram. There are different type of diagram can be plotted for steam. That diagram it can be temperature versus volume, specific volume, pressure versus enthalpy. This is, you see, the pressure versus enthalpy. This diagram is pressure versus enthalpy. P versus V, mean pressure versus specific volume. Temperature versus enthalpy, H means enthalpy, temperature versus your entropy. This is temperature versus entropy. It looks like this: temperature, entropy, and heat, and enthalpy versus entropy. These are the different types of graphs can be plotted in steam. In steam. Among these diagrams, the two most important diagram, that is temperature, entropy, that is called temperature and entropy. Entropy, temperature, entropy are normally used. Temperature and entropy, and enthalpy and entropy. Enthalpy and entropy is also used. This enthalpy and entropy is called the Mollier diagram, because it is invented by Dr. R. Mollier. R. Mollier has invented, though that's why it is this particular diagram where your enthalpy and entropy are plotted for steam. That is called the Mollier diagram. You see, this is the Mollier diagram. Here, this y axis are the enthalpy, and x axis is the entropy. You are see there, and there are different types of constant pressure lines are there. You see, these are the constant pressure lines. You see 500, 200, 100, 550, 20, like this. These lines are called the constant pressure lines. And then lines, constant dryness fraction. These are the dryness fraction line. These are the dryness fraction. These are the dryness fraction line. These are dryness fraction line. And then constant temperature line. These are the constant temperature. You see, these are the constant temperature line. Here, these are the constant temperature. Here, these are the constant pressure. Here is the dryness fraction. Dryness fraction. From this, we can come to know the enthalpy and entropy of any steam. Suppose your 20 kg pressure and 200 degrees centigrade, where this 20 kg pressure and 200 degrees centigrade cut. Suppose this it is cutting on this point, so you will come to know what is the enthalpy and what is the entropy of this. So you will directly get the enthalpy and entropy. Suppose it is at 90% 90% dryness fraction, then it will at 20 to 20 kg per centimeter square. Then this is 90% dryness fraction. It is cut here, so you can plot horizontally. You will get the enthalpy, and you will plot vertically. You will get the entropy. Like this, the Mollier chart can be studied. Then specific volume. First thing is specific volume. Specific volume means 1 kg of steam is called the specific volume of steam. The volume of 1 kg of steam is called the specific volume of steam. The specific volume of dry saturated steam is denoted by Vs. Vs is the dry saturated steam. If the steam is wet and having the dryness fraction x, then 1 minus x will be the weight of kg of water particle are suspended in x kg of steam, x kg of dry steam. So then specific volume of wet steam, where dryness wet steam, dry saturated steam plus wet water particles are there, then volume you have, if you calculate the specific volume, then you have to calculate x is the your steam into Vs is the specific volume of steam at particular pressure and particular pressure, and then 1 minus x is the water and quantity of water, and Vw is the specific volume of water. But we know water specific volume is much small compared to specific volume of steam. So if you calculate the volume of wet steam, you can ignore this particular portion. So you can write V is equal to X into Vs, meter cube per kg. Similarly, for superheated steam behave like an ideal gas. So ideal gas means P1 V1 by T1 is equal to P2 V2 by T2. PS is the saturation temperature, dry saturation pressure, Vs is the dry saturation volume, Th dry saturation temperature. Similarly, P superheater, V the superheater volume, T is the T superheater temperature. So you can, but temperature pressure is even same. If pressure is even same, means saturation temperature pressure and the superheater pressure is even same, means Ps by P superheater same. Then you can calculate what will be the volume of superheated steam, that is Vs. Vs is your dry saturated steam volume to T sup, and T is superheated steam divided by T saturation temperature. So you can calculate the superheated steam specific volume and wet steam specific volume and dry saturated steam specific volume. Now we'll describe this thing with an example. This is a good example where 2 kg of steam at pressure of 200 kg per centimeter square absolute exists in the following condition. One is wet steam. Wet steam means you have to specify the dryness fraction 0.9. Dry steam, you know, very dry saturated steam. Okay, there is no need of any specification. Only pressure is sufficient. Then superheated steam, you have to, if you want to mention superheated steam, then you have to specify the pressure as well as the temperature. Now we have to calculate the enthalpy of wet steam, enthalpy of dry saturated steam, enthalpy of superheated steam, similarly specific volume of all superheated wet steam, dry steam and superheated steam, entropy of waste steam, dry steam and superheated steam, and internal energy of waste steam, dry steam and superheated steam. ঠিক আছে? For that we have to assume the CP, specific heat at constant pressure is equal to 0.55 for superheated steam. And here the graph, molar graph, you see the unit are mentioned here, the kilojoule per kg. Then we have to convert it in MKS unit, that is 4.2 kilojoule per kg is equal to 1 kilocalorie per kg. 1 kilocalorie per kg. So from the steam table, not the diagram, from the steam table, if you see if you look at, then at 20 kg centimeter square and wet steam of dryness fraction 0.9, then you will get or superheated steam at 250 degrees centigrade. All this figure you will find out. That is called for steam table at 20 kg per centimeter square. HW is equal to 216. L is your latent heat, that is the sensible heat, that is the latent heat. So what is the total heat? Now sensible heat plus latent heat, that will give you 668 kilocalorie per kg. That is equivalent from here by graph also you can calculate at 20 kg. You see the 20 kg coming is like here, 20 kg is coming here, and here 20 kg coming here. You are getting the value of 2803 divided by 4.2, as it is kilojoule per kg. So you have divided by 4.2, you are getting 668.7. 668.7. Similarly, superheated steam, it is 250 degrees centigrade, 20 kg per centimeter square. If it is cutting here, so you are getting 2900 divided by 4.2, that is equal to 689 kilocalorie per kg of steam. That is superheated enthalpy, that is called the saturated enthalpy. Enthalpy like this. So, and for specific volume also, from table we are going to get, from the steam table we are going to get specific volume of water. This is the specific volume of steam. Water is very less, and steam, this one is entropy of water, entropy of water molecule, entropy of steam, entropy of steam. You can find it from the diagram also. And SL is equal to SS minus SW, that is, these are, if you divide the W, that is 0.9338 kilocalorie per kg per degree Kelvin. From the diagram also you can find out. Then enthalpy of wet steam will be how much? HW plus SL wet steam, 0.9 into latent heat. 0.9 latent heat is 452, you see 452.9 plus your sensible heat, that is your 216. So this will give you the enthalpy of wet steam. The total steam is how much? Now 2 kg. So you have to multiply it by 2 into this. That will give you the enthalpy of wet steam, that is 1244 kilocalorie for 2 kg of 2 kg of steam. Similarly, for dry saturated steam, you see the enthalpy, that is equal to 668 into 2 kg, that will give you 1337. Similarly, total energy of superheated steam we have calculated, that is the enthalpy 689 into 2, that is equal to 1379. So this is the enthalpy of wet steam, enthalpy of dry saturated steam, is the enthalpy of superheated steam. Similar way, we can calculate the specific volume of wet steam, that is zero point 0.9 into you see the VW is 1016, you see 10.1016, that is 0.0991. For 2 kg, it will multiply by 2, that will give you 0.18288, that is the specific volume of wet steam. Specific volume of dry steam will be 2 into 1016, you see 1016, that will be your specific volume, that will be 0.2032. And specific volume superheated steam, that is that the formula we know, superheated Vs T superheater by 2 temperature, saturation temperature, that is 0.1016 divided into 523 divided by 484, that is equal to 0.1096 meter cube per kg. So specific volume of waste steam will be 0.1828, specific volume of disaturated steam will be 0.2032, specific volume of superheated steam will be 0.2192. Similarly, the entropy also for the waste steam, it is X into XL. XL, you know, we have calculated. XL value we have calculated. XL value in the previous page. XL value we have calculated. XL, you see XL 1.5158. You see XL 1.5158. XL, XL is equal to 0.9338. XL is equal to you see point for you see XL is equal to 0.9338. So XL 0.9 into XL into XW, XW so entropy. So this will be the waste stream. Entropy of waste stream, of entropy 2 kg, that's multiplied by 2, that is 2.844. This for 2 kg. Similarly, entropy for disaturated steam, directly you can calculate, that is 2 into 1.51, 51, that is 3.03316. Entropy of superheated steam, that is same formula. This formula you are going to use, SWSL. This is the formula. If you use this formula, you will get 1.52424. So this is the entropy of 1 kg steam, and the entropy of 2 kg steam will be 3.04, something like that. So it is wet steam, this is the saturated steam, and this is the this will be your superheated steam. Similarly, internal energy also, if you use this formula, H minus PV by J, PV by J, then you will get for wet steam it is 11.62.4. For dry steam it will be 1242.2, and for superheated steam again the same, superheated steam it will be 1276.91 for 2 kg of steam. I have to multiply by, first you have to calculate for 1 kg, then multiply by 2 for 2 kg. So if you see the tabular form, you see the enthalpy for wet steam is 1244, disaturated steam is greater 1337, superheated steam for 250 degrees centigrade, it is further in greater than this. Similarly, volume is also, you can see wet steam it is less, disaturated steam it is slightly more, and superheated steam it is still more. Entropy is also like that, 2.8 for wet steam, disaturated steam 3.03, and for superheated steam it is more. Similarly, internal energy 1162, 1242 disaturated, and 127 again for the superheated steam. So now I have discussed about the all the three cases for wet steam, disaturated steam, and superheated steam, for your enthalpy, your specific volume, entropy, and your internal energy. Then the question, now one question may be asked, why superheated steam being inserted in the turbine in initial stage? The answer is the 4, 5, 6 answer is there. Because when superheated steam, why superheated steam being inserted in the turbine initial stages? Why? Now, to prevention the moisture formation at the turbine inlet, steam has the greatest pressure and temperature. So steam has the greatest prevention to moisture formation. Moisture formation at the turbine inlet, the steam temperature has to be high pressure and temperature. If saturation temperature steam are used, if we use the saturation temperature steam and steam is used, then it would started condensing very early during expansion, because the pressure is coming down, so it will be condensation will take place. Superheating ensure that the steam remain dry for a longer portion of the expansion, and reducing moisture content in the latter stage also. This prevent the erosion and pitting of the turbine blades, because as there is no water formation, if superheated steam is enter at the initial stage, after expansion also it will remain dry saturated up to last stage, so there will not be any water formation, and when water formation will be there, high momentum, the water particle will strike the blades and erosion will take place. Then second one is high thermal efficiency, because we know the high superheated steam having the more enthalpy, that's why your efficiency will increase. Output will also increase, because as superheated steam is having more enthalpy, so your output is also going to increase. Energy, your in the thermal efficiency also going to increase. Your power output also going to increase, because the enthalpy is more. Use heat losses will be also very less, and then improve blade life and reliability, because there is no waste steam, there is no damage in the last stage of the blade, so your reliability of the blades will increase, and better control or expansion process, because there is no water formation. So in short, we can say, if you use the superheated steam admitted in the initial turbine stages to maximize the one is efficiency, output that is due to the high energy, and protect the blade from the moisture formation, because moisture related damage that will be avoided if you use high superheated steam at the beginning of the turbine. Dryness fraction, you see, I have told you the 100% in the boiler you can produce steam 100% saturation, but if you want to get superheated steam, the saturated steam has to pass through the superheater. Once it pass through the superheater, steam will become super saturated, it will be super saturated, superheated. Then dryness fraction, suppose once your steam is having dryness fraction of 10, means water content but by mass is 10, then it should be 10%, 90% dry, and having the dryness fraction of 0.9. Steam dryness fraction important, because total amount of transferable energy content within the steam with affect the heating efficiency and quality. So if you suppose for 2 kg steam, same example, 20 kg per centimeter square pressure, you see with dryness fraction 0.9, your enthalpy will be how much? 1.62. For dry saturated steam, you can see it is 1242, and for superheated steam at 250 degree centigrade, 1379. So superheated steam enthalpy is more, so dry saturated steam and it is less, and wet steam it is further less. So and superheated and dryness fraction is ms, mass of steam divided by mass of your steam plus water, that will give you the dryness fraction. So you can see dryness fraction, importance of dryness fraction for enthalpy. And then superheated steam, where we are using the superheated steam, the captive power generation, or superheated steam we are using in the turbine to drive compressor, fans, blower, pump, etc. Saturated steam we are using process heating. In the process heating, we are using saturated steam. Why saturated? Question now asked you, when the superheated steam having the large quantity of your enthalpy, then why the saturated steam are being used for heating purpose? for heating purpose. That is the answer is like this. Your first question answer we have already told, that is the turbine. Why turbine superheated steam is used, and why saturated steam is used for a process heating. These are two questions can be asked. Saturated steam, superheated steam can be used, that I already told you, that saturated steam would get wetted and wetter and water as it went through the successive stages. So if you use that saturated steam or wet steam, it will be wetter and wetter, and it will damage your turbine blades. Damage your turbine blades. That's why in turbine we are going to use superheated steam. But in the why condenser or why or heat exchanger we are using saturated steam, because the answer is the superheated steam has to cool to saturation temperature before it can condense and to release its latent heat. Because in the heat exchanger we are using the latent heat of or heat of steam. That heat is tremendous amount of big amount of heat that can be converted in that heat can be transferred to the process. So, and superheated steam, if you use the conversion of superheated steam will take long time to long time, but long time. The amount of heat given up by the superheated steam as it cools to saturation temperature is relatively small, and in comparison to its enthalpy of evaporation, in compared to its enthalpy of evaporation, latent heat is very big. Evaporation is very big, and latent is very big, but superheated steam to latent heat is very small amount of heat, and it will take long time to require to reach to the dry saturated to the superheated steam to dry saturation steam. That's why higher degree of superheat, relatively longer is the time it takes to cool, and during this time the superheated steam is releasing very little energy of little energy, because superheated steam having no doubt having higher energy, but to reach up to the dry saturation steam, it will take long time. It will take long time to cool. That's why your exchanger size will be very big. That is not acceptable. So you have to make desuperheating. If you are using superheated steam, you have to make a desuperheating zone in your heat exchanger to cool it fast, and then you can utilize the latent heat of the dry saturated steam to exchange the heat. Has to cool to give up heat, and whilst the superheated steam changes the phase, the create temperature gradient over the heat transfer surface, it cools to saturation temperature. Then require larger heat transfer area, I have told you. And not only that, you see the condensing steam film coefficient is as high as coefficient is as high as 8,000 to 10,000 kilocalorie per hour per meter square per degree centigrade. However, the it is for steam, it is for steam, it is less than only 1,000 kilocalorie per hour per meter square per degree centigrade. So the film coefficient of steam is less compared to the condensing steam. It is very high. That's why heat transfer will be more if you are using the latent heat instead of the superheated steam. So I think I have discussed all the properties of steam, its importance, enthalpy, entropy, specific volume, and internal energy. Then wet steam, dry steam, and dry-saturated steam and superheated steam. And I have given you example for how to calculate the enthalpy, entropy, internal energy, and specific volume. Superheated steam behaves like a ideal gas. P1 V1 by T1 is equal to P2 V2 by T2. So if you want to the pressure is same. So if you want to find out the volume or temperature, just using the formula, you can easily calculate. Again, and last, and then why saturated steam is used for heat exchanger, Why superheated steam is used in the turbine initial stage, that also clearly explained. So I think if you go through the slides, your concept will be totally clear. If you don't have still have any doubt, you can call me with my phone or with my mobile number, or we can arrange a video conference. And if you are satisfied, please give a tick mark and subscribe this channel so that you will get information. A lot of posts are going to come in boilers. You will be please be with this channel, so your concept regarding the boiler will be totally clear once I go on posting lot of post for boiler, and it will be helpful to you, and not only you but also your friends and your seniors. So be in this channel, subscribe this channel, and go through this channel. And I think if you go through this channel, you will be able to answer all the questions being asked to you in the interview board. Thank you very much.